what we're going to talk about is dictionaries. And the motivating question of this topic is, what if we want to somehow store expressions that relate to each other? For example, if I want to store members of a club and their respective positions, how would I do that? Do I need to keep track of two different lists and somehow join them? Like, this seems pretty tricky. So what we're going to talk about today is dictionaries, which are unordered collections of key value pairs. And key and value, so the key value pair is what stores these related expressions. So, and the best way to see this is, I'm just going to go through examples. So let's say, I don't know, I'm feeling fruits today. Let's say I like fruits. Alright, so what I'm going to do is I'm going to define apples. How many apples did I buy from the grocery store? I bought 2. And I want to buy also, what other fruits are there? Oranges. I bought 3 of those. Okay? So, if I have my fruits, I have apples and oranges. Cool. Alright. So, this is basically defining a dictionary. Alright? And it's defined by the curly brackets. And the apples and oranges in this case, because they're before the colon, are keys. And the values are the numbers I associate with them after the colon. So, now if someone asks, hey, how many apples did I buy? Well, all I have to do is I just have to access the value using the key. So, how do I do that? It's the same index type of notation. So, except now my index is a key, and I get the value. So, this is how dictionaries are pretty useful. Okay? I can also get the length of a dictionary. So, the length of the fruits is going to tell me I made I have 2 types of fruits, basically. Now, let's say I decide to go on another shopping spree, and I go for my favorite fruit, which is a mango. And so what I'm going to do is I can define mangoes. How many mangoes did I buy? Well, I went really crazy, and I decided to buy 10 mangoes. So let's see how many fruits I have now. Oh, I have mangoes. 10. Okay, this is actually interesting too, because you notice that right now it seems to be in order, but that doesn't necessarily have to be the case. Dictionaries are unordered collections of key value pairs. So let's actually see. So if I add another fruit, let's see, fruit pear. Okay, and I bought 1 of those. Let's see what my fruits looks like. So notice that pear ended up here. So, again, the order doesn't necessarily have to be what we think it is. So, you would intuitively think that this goes at the back, but dictionaries are unordered, so do be aware of that. Alright, so now let's say I want to check, hey, did I buy any bananas? So I can do the same, because the dictionary is inherently a sequence, I can do the same inclusion operation. So, is bananas in my fruits? And that's obviously not true, because I didn't buy any bananas. So, that's the way this works. And let's say I want to print out the elements of my dictionary. I can do a for loop. So when you iterate over a dictionary, it iterates over the keys. So I'm going to say for item in my fruits. So the item is now bound to a key. I want to print my key and the value associated with the key. How do I get the value associated with the key? I call fruit on the item. Sorry, not call. I access the value using the key, and you get the following. So this is some pretty simple dictionary operations. And so notice that here, so here's a demonstration of the key and value idea. So these are the keys and these are the values. Alright, now let's look at an interesting example. Let's say I want to define the following function. It's called character tracker, and I give it a string as a word and a particular letter, and it returns a number of times a letter occurred in the word. Okay. So hello, for example, occurred. L occurred twice in hello, so it returns 2. S has 1 occurrence in numbers, so it returns 1. And nothing has no occurrences of W. So this is what the character tracker does. Alright. So, well, I know immediately, the first thing I can think of is if I know the letter is not in the word, then I know I can return 0 for that, right? So that's a pretty easy case. if letter not in word, I can return 0. And then now, if it's the case, so what I need, see, now here, the key thing to notice is that I need to somehow keep track of the count and the word, the letter associated with that count. So this is why a dictionary is very useful, because it's a very easy way to keep track of these two things. So I'm just going to define my tracker, basically. I'm going to call it a tracker. It's going to start out as an empty dictionary, because I don't know what's going to be in it. Okay? And so what I'm going to do now is I'm going to go through each character in my word, and if my character is already in the dictionary, if my character is in the tracker, basically, what I want to do is I already know there's some value associated with it, right? So I'm just going to call my tracker. I'm going to access whatever character it has, and I'm going to increment that. And then otherwise, I know that this is the first time the tracker has seen this letter, so I need to make a new entry in the dictionary. So I'm going to call tracker on character is equal to 1. So this is the first occurrence of that character inside the dictionary. So now, what I can do at the end is I can just return tracker on whatever letter I wanted to check. And this will give me whatever was in the dictionary, the value associated with that letter, and that's the count. Because this is essentially what we did, we counted it. Alright, so let's test this out. Should work. And it works. So that's an example of a pretty nice way you can use a dictionary. So this, whenever you want to keep track of multiple things and associations with each other, a dictionary is your best bet. And there are some other reasons we'll talk about later as to why you would use a dictionary. But in my opinion, dictionaries are one of the most useful types. It's actually called one of the data structures in Python. And this is, again, dictionaries are something we'll talk about a lot more later on in the course. And also, one quick thing I do want to talk about. What can be keys and values? So here you've seen a lot of examples with strings being the keys and numbers being the values. This doesn't always have to be the case. It turns out that a lot of applications that does end up being the case, but I can even define some dictionary being like numbers mapping to another number. So like if I want to map every number to its n plus number plus 1 number, I can do this. So this is a perfectly viable dictionary. Now, there are some restrictions on what can be a key. You can even have a list or a dictionary itself as a value. So, but one thing you can't have as key is you can't have mutable values as a key. And we've already seen a mutable value. We've seen the list as a mutable value. Dictionaries are also mutable values. So what you can have is you can't have a mutable value as a key. And if you try to do it, you'll get this very interesting error called unhashable type list. Okay, so I won't really talk about this error right now, but this is going to be another preview for the next course in this series called Data Structures and Algorithms, and we'll really investigate why this happens, because this has to do with the underlying implementation of how dictionaries work in Python. So that's a little sneak peek for next time. But anyway, that's all I have for today. Thanks for watching. So as a quick summary, what we basically went through today is we went through strings, some operations you can do with strings, some interesting questions with strings, and then we looked again at the range function. So the range function is very useful in defining consecutive numbers. And then we looked also at mutation. Mutation is very useful if you want to change things in place. And then lastly, we looked at dictionaries, which is again a very useful concept. So that's all I have for today. Thanks for watching. I'll see you next time.